Hello everyone. So in this video I'm going to show you how to solve linear differential equations of the form dy by dx plus py equals q, where both p and q could be constants or functions of x. And the methods we've learned so far for differential equations, separating variables and the reverse product rule, won't work for equations of this form. So what we need is what's called an integrating factor, and this is e raised to a power of the integral of p dx. And once we have this integrating factor, we multiply both sides of a differential equation by it. So this will make more sense as we work through example 1. We've been asked to solve a differential equation dy by dx plus y is equal to x. And you'll notice that in this form, the reverse product rule and separating variables won't work. So we need to use this integrating factor. And can you see that the value of p in this form is 1? So we can say that p equals 1. And now we need to work out the integrating factor, which is e raised to a power of the integral of 1 with respect to x. And the integral of 1 dx is just x. So the integrating factor, which I'll call if, is equal to e to the power of x. So now we need to multiply both sides by e to the x. Now we get e to the x dy by dx plus e to the x times y is equal to x times e to the x. And because we've multiplied it by both sides, the differential equation remains balanced or unchanged. But can you see that now we can use the reverse product rule, where the derivative of e to the x is e to the x, and the derivative of y is dy by dx. So now we can say the derivative with respect to x of e to the xy is equal to x times e to the x. And now to work out what y is, we need to take the integral of both sides with respect to x. So e to the x times y integrated with respect to x is equal to the integral of x e to the x dx. And we can integrate this using integration by parts, where u is equal to x, so du by dx will equal 1, dv by dx will equal e to the x, so v will equal also e to the x. So I can substitute these back into here, and on the right hand side, this dx will cancel with this one, the integral and the derivative will cancel, so we have e to the xy is equal to uv, so x e to the x minus the integral of v du, which is 1. This will integrate onto itself, so we have e to the xy is equal to x e to the x minus e to the x plus the constant of integration. And now to work out y, we need to divide everything by this e to the x. So y will equal x e to the x over e to the x minus e to the x divided by itself plus c over e to the x. So these two will cancel, as will these. So we're left with y is equal to x minus 1 plus c e to the minus x. Okay? So all of this was possible because we multiplied both the left and the right hand side of this differential equation by the integrating factor. Okay, so let's try question 2. Okay, so in example 2, we've been given this first order differential equation, and we've been asked to find the general solution. But if you notice this x here, and if we go back to our example at the start, the coefficient of dy by dx is 1. So this means that we need to cancel out this x. So we'll divide both the left and the right hand side by x. So we get dy by dx plus 2 over xy is equal to 3 over x e to the x. And now we need to work out the integrating factor, which is e to the integral of p integrated with respect to x. And in this case, p is 2 over x. So we need to work out the integral of 2 over x with respect to x. And this is 2 times the natural log of x. And using the power rule of logs, we can raise this x to the power of 2. So this becomes the natural log of x squared. So putting this back into our integrating factor, we get e to the natural log of x squared. The natural log and e will cancel. So our integrating factor is simply x squared. So now we need to multiply both sides by x squared. So x squared dy by dx plus 2 over x squared y is equal to 3 over x squared e to the x. And can you see that this division of x and x squared will cancel? And the same here. So we can tidy this up as x squared dy by dx plus 2xy will equal 3x e to the x. And now we can use the reverse product rule, where the derivative of x squared is 2x and the derivative of y is dy by dx. So d by dx of x squared y will equal 3x e to the x. We'll take the integral of both sides, so we get x squared y is equal to, and I'll move this 3 out in front, so x e to the x integrated with respect to x. And again, we can use integration by parts to integrate this. So this becomes x squared y is equal to 3 multiplied by x e to the x minus the integral of e to the x dx. So x squared y becomes 3x e to the x minus the integral of e to the x is e to the x plus the constant. And dividing 3 by x squared, we get y is equal to 3x e to the x minus e to the x plus c, all divided by x squared. Okay? So let's try just one more question. Okay, so in question 3, we've been asked to solve this differential equation, but this time we've been given that y equals 1 and x equals 0. And what this will allow us to do is to go from a general solution to the particular solution. So the first thing we need to do is to work out the integrating factor, which is e to the power of p, which is sec squared x, integrated with respect to x. And the integral of sec squared x is a standard integral, and this is e to the 10x. So now we'll multiply both sides by e to the power of 10x. So we get e to the 10x dy by dx plus e to the 10x y sec squared x is equal to e to the 1 minus 10x times e to the tan of x. And again, we can use the reverse product rule, where using the chain rule, the derivative of e to the 10x is sec squared x e to the 10x, and the derivative of y is dy by dx. So this becomes d by dx of e to the 10x times y is equal to the right hand side, where we can simplify the powers by adding this 10x to this negative, so it becomes 0. So this just leaves us with e. We'll integrate both sides. So we get e to the 10x y is equal to the integral of e with respect to x. So e to the 10x times y is equal to ex plus the constant. And at this point, we can substitute in y equals 1 and x equals 0. So we have e to the tan of 0 times y is equal to e times 0 plus the constant. Well, the tan of 0 is 0, e to the 0 is 1, times this by 1 and we get 1. E times 0 is 0, so the constant, c, must be equal to 1. I'm just going to block this off to make it a bit tidier. And then we can substitute this value of c back into here. So e to the 10x times y is equal to ex plus 1. We'll divide both sides by e to the 10x. So y is equal to ex plus 1 all over e to the power of 10x. Okay? Well, I hope that's given you a clearer idea on how to use the integrating factor for linear differential equations. If you found that helpful, please hit that like and subscribe button, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.